In Module 15, we'll be working with logarithmic functions. A logarithm is an operation that you probably haven't seen before. It's the inverse of an exponential function. So if for some reason you needed to, if you had a variable located up in the exponent and you needed to cancel out the base, that's what you would use a logarithm for. Just like with other operations you've seen before where addition is the inverse of subtraction, but you can express subtraction using addition. It's the same as adding a negative. Multiplication and division are inverses, but you can express one as the other. Division is the same as multiplying by a reciprocal. With exponents and radicals, those are inverses of each other. They cancel each other out, but you can also express a radical as a fractional exponent. Logarithms and exponentials are also inverses of each other, but you can express one as the other. So here's a conditional statement that says if I have some base that's being taken to a power, and that's equal to something else, I can rewrite that by saying the log of that base. Okay, I would keep the same base. I can just flip-flop, change the x and the y. You know, with inverses, you can change the input and the output. The log base b of x is equal to y. Just to give you some numbers to kind of give you an idea what that means. We all know that, let's say 5 to the third power is equal to 125. Well, the log base 5 of 125 would then be equal to 3. If you enter, if you know how to key in this into your calculator, it will give you 3. A common log, when you write just the word log, and you don't see, normally when you write a log, you're supposed to write a base next to it. You just saw me write log base 5. I can write log base 2. Typically, you're supposed to, as a subscript, the smaller number, you're supposed to write the base next to a log. I could maybe kind of relate that to an index on a radical, where you're supposed to write the index unless that index is a 2. And in that case, that would just be a square root. Well, if you don't write the base next to a log, that's known as a common log, and that base would be 10. If you don't see it written, the number that's there is a 10. That's called a common logarithm. That is, in most calculators only perform 2 types of logs. One would be a common log where the base is 10. The other type would be a natural log. Now, there are some calculators nowadays where you can pick whichever base you want to put, but still the majority of them only perform these 2 logs. So the base of a natural log is a number known as E, or Euler's number, which is an irrational number. It goes on forever. Rounded, it would be approximately 2.718. So, oh dear, this is giving me problems again. So, if you were to ever see ln is what a natural log shows up in on a calculator. It's the symbol for natural log. If you say ln of some other number, that's the same thing as just saying log base e. When your eyes see ln, but your mind should just read log base e. It means the same thing. Now, once we get into graphing these, okay, the parent, the basic shape that a logarithmic function would take, if you have a base of a log that's greater than 1, those functions increase, but at a decreasing rate. As you go from left to right, it's always going to go up, but it will start to flatten out. If you have the base of a log that's between 0 and 1, or a proper fraction, that will decrease, but at a decreasing rate. As x gets bigger, the y is going to get smaller, but it's going to start to flatten out. It's not going to be as steep. And just like with other functions, transformations can be performed with these. So here's where you would find your transformations. Because just like with exponentials, we used b. B is the most commonly used letter to be used for base. We'll use C again for horizontal stretch or compresses, but here's where you would find your A, your C, your H, and your K. When you perform a transformation, you would get a set of parent points, and you would apply the transformations as it shows here on the bottom of the screen. X divided by C plus H, Y times A plus K. Whereas exponential functions have a horizontal asymptote, logarithmic functions have a vertical asymptote. Vertically, we know what an asymptote is from our rational functions, but vertically there will be some number where your graph approaches but it never touches, and the location of that will always be at x equals h. X equals means that it's vertical. H would just be where that vertical line would be located.